Alright, so in this video we are going to talk about the derivatives of sine and cosine. So we know how to find the derivatives of power functions, but we do not know how to find the derivatives of trigonometric functions, which is what sine and cosine are. So we're going to use the definition of the derivative to find these things. Before we do, I need to remind you of a couple things. I need to remind you of the sum difference formulas. So we know that the sum, so sine of A plus something else, B, is actually, sine of A cosine B plus cosine A sine B. And if it's a difference, sine of A minus B, it's sine of A cosine B minus cosine A sine B. For cosine, the sum of two terms, cosine of A plus B, is actually cosine A cosine B minus sine A sine B. Okay, so you flip the sign here. For cosine of A minus B, it becomes cosine A cosine B plus sine A sine B. I don't have time to prove this, but just memorize these identities, okay? An easy way to remember is sine, cosine, cosine, sine. And then cosine is cosine, cosine, sine, sine, switched to the middle, okay? All right, the other thing we're going to use for this proof is that the limit, you prove this in class and in your quiz, the limit as x approaches 0 of sine of x over x is 1. We did not prove this, but take it as fact for now. The limit as x approaches 0 of 1 minus cosine x over x is equal to 0. We'll prove this later, but for now, remember these two as well. So with all this, we're going to actually find the derivative of sine and cosine using the definition of the derivative. So let's start with sine. Ooh. So let's start with sine. Oh goodness. Okay. There we go. Okay. So we want our function to be sine. We want to find the derivative, which we know is the limit as our x values get closer together of our change in y minus our change in x. So our function is sine of x, so this is the limit as h approaches 0 of sine of x plus h minus sine of x all over h. So we can use the sum difference identity right here. So limit as h approaches 0 of actually sine cosine plus cosine sine minus sine of x over h. Okay, now you notice these two terms right here both have sine of x. So I'm going to put them together. So we're going to just move this over here, no big deal. So this becomes limit as h approaches 0 of sine of x cosine h minus sine of x plus cosine x sine of h, and then all over h. So these two both have sine of x, so I can factor that out. So I'm left with the limit as h approaches 0 of sine of x. Factor that out, I'm left with cosine h minus 1. Again, factoring is like dividing. So it's like I divided this by sine of x, and I divided this by sine of x. So then I'm left with cosine h. This is just minus 1. Okay? Plus cosine x times sine of h all over h. Okay, my goal is to start making things look like this. These two right here. Because I know what they are. I know that the limit as x approaches 0 of sine of x over x equals 1, and so on. And so I'm looking at something that is approaching 0. And I'm starting to see, oh look, I look like kind of what I want. So I can break these two up, put them over a common denominator. So, over here, I'm going to put it on the side. I'm going to know that 1 plus 3 over 2 is actually the same as 1 half plus 3 halves. Yeah, I just put them over a common denominator. So I can split these two up. I can put this as sine x times cosine h minus 1 all over h plus cosine x times sine h over h. I also know that if I have something like 3 times 2 over 2, this is the same as 3 times 2 over 2 because I'm just multiplying to the numerator. Okay, so I'm going to put that on the side again. So I can split these up right here. So this is then the limit as h approaches 0 of sine of x times cosine h minus 1 over h plus, so that's one term, cosine x times sine of h over h. That's another term. So I'm starting to look like what I want, except this one is flipped. So we want the limit as x approaches 0 of 1 minus cosine x. Over here, it's backwards. It's cosine minus 1. So I'm going to factor out a negative. So the limit as h approaches 0 of negative sine x times minus cosine h plus 1. And then over here, cosine x times sine h over h. Now I have what I want. I have the limit as h approaches 0 of minus sine x times 1 minus cosine h over h plus cosine x times sine h over h. Okay? We know that then as h approaches 0, this approaches 0. And as h approaches 0, this approaches 1. So we are left with the limit as h approaches 0 of minus sine x times 0 plus cosine x, which is just equal to the limit as h approaches 0 of cosine x, which is equal to cosine x. So the derivative of sine x is cosine x. And you can actually see that if we graph sine of x, so here's sine of x, and it looks like this. If we look at sine of x, we can see that its slope, so at 0, the slope, or here at different points, our slopes look like they're increasing. And then here they decrease, or they become 0. And then they start decreasing. And then again, they become 0, and then they start increasing. So as you can see, as we go from 0 to, let's say, 2 pi, okay, our slopes first increase, then become 0, then decrease, slow down, become 0, then increase, slow down, become 0, and so on and so forth. The function that does that, if we compare, so at 0, we're increasing. So we're increasing till we hit 0. And then we start slowing down until we hit 0 right here. And then we start decreasing, slowing down until we hit 0, which is right here. Slope is 0. And so on and so forth. You see that the slope function actually starts resembling cosine of x. So here's sine of x, and here's our slope function, cosine of x. Now that you know this, I asked you in class to then find the derivative of cosine of x. So here's cosine of x, okay? And we want to find its derivative using the definition. So we know it's the limit as h approaches 0 of our change in y over our change in x. Let me do this for you really quickly. My advice is you try to do this on your own. Again, we're going to use the sum difference formulas and the two limits we talked about earlier. So we know that f prime of x is equal to the limit as h approaches 0 of cosine of x plus h minus cosine of x all over h. We use the sum difference formula. We know that cosine of x plus h is actually cosine x cosine h minus sine x sine h minus cosine x all over h. We then put this together with this term because they both have a cosine x. So that's the limit as h approaches 0 of cosine x cosine h minus cosine x minus sine x sine h. And we can split them up to be both b over h because they have a common denominator. We can then factor out a cosine on the numerator here. We're left with cosine x times cosine h minus 1 all over h minus sine x sine h over h. Again, we want to factor out a negative, so this starts looking like the term we want. So we are left with the limit as h approaches 0 of negative cosine x times 1 minus cosine h over h. That's one term. Minus sine x times sine h over h. Okay. This becomes 0. This becomes 1. We are left with the limit as h approaches 0 of negative cosine x times 0 minus sine x times 1, which is just the limit as h approaches 0 of minus sine x. There's no h value, so this is just negative sine x. So the derivative of cosine is actually negative sine x. And again, you can confirm that with a graph to help you kind of understand it a little better. So we learned two things. We learned that the derivative of sine x is cosine. And the derivative of cosine is negative sine. Okay? So my question to you, my challenge question, is what do you think is the 1,000th derivative of sine? So I'll give you like a start. If our function is sine, our derivative is cosine. Our second derivative is the derivative of cosine, which is negative sine. Then our third derivative is the derivative of negative sine, which is negative cosine. And so on and so forth. So see if you can find the 1,000th derivative of sine using these two properties right here. I would advise that you try to go through these to understand how we found them. Here, try to answer the challenge and do some example problems. So find the derivative of negative 3 sine x plus 4x and cosine x plus 2x squared minus sine x. Okay? So try to find the derivative of these two and try to find the 1,000th derivative of sine.